Welcome to a complete walkthrough of the Boeing 737 fuel system. We are going to see, section by section, how the aircraft stores its fuel, how it pushes it to the engines, how the pilot knows at all times how much is left and where, which warnings come up when something goes wrong, and even the system that keeps the tanks from exploding. This is the index of what is coming. Let's begin. An airplane doesn't just drink fuel on its own. You have to push it from the wing tanks to the engines, make sure it arrives with enough pressure, and be able to move fuel from one side to the other if needed. All of that is governed from a single plate on the cockpit ceiling. Let's take a look at the fuel control panel, the engine room of the fuel feed system. Look up at the overhead panel at the front of the ceiling. There, on the forward overhead panel, you have this plate full of switches and lights. Notice that it's divided into two symmetrical halves, one for each engine. Let's go through its controls from bottom to top, following the path of the fuel. Let's start with the heart of the panel, the pumps. These are the fuel pump switches, the fuel pump. Fuel doesn't climb up on its own. Each tank has electric pumps that push it under pressure toward the engines. At the bottom, you have the main tank pumps, 2 per wing, marked aft and forward drive for tanks 1 and 2. And in the middle, the center tank pumps, the L and the R. Each switch is simple. On turns the pump on. Off turns it off. And how do you know if a pump stops pushing? With these low-pressure lights, the low-pressure lights of the main tanks. They come on in amber when that pump isn't delivering pressure or when you've left it switched off. And these other ones up here are the low-pressure lights of the center tank. There's a subtlety here. If you leave a center tank pump on and it loses pressure, besides the light, you also get the cockpit's general alert, the master caution, because losing that fuel changes your flight plan. Normally, each engine drinks from its own side, separately, but sometimes you need one engine to drink from the other side's tank, because of a weight imbalance between wings, or if a pump fails. That's what this central selector is for, the crossfeed. When you open it, a valve joins the two feed lines and fuel can cross from one side to the other. And this blue light, the valve open, confirms at a glance that the crossfeed valve is actually open. Before reaching the engine, the fuel passes through a filter. If that filter gets dirty and is about to clog up, these filter bypass lights come on in amber. It's a maintenance warning. The system will keep delivering fuel by bypassing the filter, but it's telling you that filter is due for an inspection. And at the very top, the most serious lights on the plate. These are the eng valve closed and spar valve closed lights. Each engine has valves that cut off the fuel completely, one at the engine itself and another at the wing spar. These lights tell you whether those shutoff valves are closed or in transit, something that only happens when you shut down an engine or pull the fire handle. With everything normal, they stay off. And we have one last detail, discreet but important. This indicator in the top corner, the fuel temp, shows the fuel temperature of tank number 1. Why does it matter? Because at high altitude it gets bitterly cold, and if the fuel gets close to freezing, the pilot has to act, descend, speed up, or find warmer air before ice crystals start to form. And that's the fuel control panel. Pumps that push the fuel toward the engines, lights that warn you if they lose pressure, a crossfeed to move fuel from one side to the other, a dirty filter warning, shut-off valves for emergencies, and a thermometer so the fuel doesn't freeze up there. The airplane's entire fuel feed, governed from one plate on the ceiling. In the previous video, we saw the plate the pilot uses to govern the fuel. But what's behind those switches? Which way does the fuel travel from the wings to the engines? This is the complete schematic of the system, the map of lines, pumps, and valves that feeds the airplane. Let's walk through it, following the path of every drop. The airplane doesn't carry its fuel in one single place. It stores it in 3 tanks. Number 1 in the left wing, number 2 in the right wing, and a center tank in the belly between the 2 wings. Each engine drinks, in principle, from the tank on its own side, and the center tank is the big extra for long flights. Fuel doesn't climb up to the engines on its own. It has to be pushed. Each main tank has 2 electric pumps, one forward and one aft, the FWD and AFT we already saw on the plate. They keep the fuel under pressure on its way to the engine. The center tank hides the trick of the whole system. It has its own 2 pumps, and they push with more pressure than the main tank ones. That's why, as long as there's fuel left in the center tank, the engines drink from it first and the wing tanks stay full. It's exactly what the schematic shows. Engines running, the center tank feeding them. Follow the pink line. From the pumps, the fuel runs along the feed lines toward each engine. Normally, each side works on its own. But in the middle, there's a valve that joins the 2 lines, the crossfeed. Open it, and one engine can drink from the opposite side to balance weight between wings or if a pump fails. Before entering the engine, the fuel passes through 2 emergency taps. They are the shutoff valves in series, the one at the wing spar, the spar valve, and the one at the engine itself, the engine valve. They close when you shut down the engine or pull the fire handle, and they leave the engine without a single drop. The engine isn't the only one that eats. The auxiliary turbine in the tail, the APU, takes its fuel from the tank number 1 line with its own shutoff valve. It's the one that provides electricity and air on the ground with the engines shut down. And how does the fuel get into the airplane? Through the fueling station on the right wing. A single pressure connection fills all 3 tanks from the truck. Right next to it, the manual defueling valve allows the opposite, taking fuel out of the airplane when needed. There's one last, well-thought-out detail. When the center tank is running empty, a small ejector, the scavenge jet pump, collects the fuel from the bottom and transfers it to tank number 1. That way, not a single drop of the center tank goes to waste. And that's the complete fuel system. 3 tanks, pumps that push, the center one's harder so that fuel gets used first, a crossfeed to cross sides, shutoff valves for emergencies, a feed for the APU, the fueling station, and even a scavenge to drain the last drops of the center tank. Everything that lives behind that plate on the ceiling. Now that you know the map, every light and every switch on that plate makes sense. Before takeoff and all through the flight, a pilot has to answer a very simple but very serious question. How much fuel do I have left? And where is it? The answer is on these 3 gauges on the upper screen. They are not there for decoration. They tell you whether you will reach your destination with margin to spare or whether it is time to divert. Look down at the center of the instrument panel at the upper screen. There, on the upper display unit, you will find the fuel quantity indications. You will see 3 gauges in a row, and that is no coincidence, one for each tank. Let's learn to read them. Let's start on the left. This is the tank number 1 indicator, the one for the left wing. Notice that it gives you the figure in 2 ways at once. The big white number is the digital readout, the exact kilos left in that tank, and the white arc around it is the analog readout, so you can tell at a glance whether the tank is full, half full, or almost empty without reading the number. Everything it shows is usable fuel, the fuel the engines can actually burn. In the middle, you have the special one. This is the center tank indicator, the CTR, a tank that sits in the body of the airplane between the two wings. It is normally the first one to be used because you want to burn off that weight in the middle first and keep the wings loaded as long as possible, since they handle the stress of flight better that way. When the center tank reaches zero, the airplane switches over to drinking from the wing tanks. And on the right, its twin, the tank number 2 indicator, the one for the right wing. Identical to the first, and for a good reason. The pilot is constantly comparing tank 1 and tank 2 to keep both wings weighing roughly the same. One wing much heavier than the other unbalances the airplane, and that is why checking that these two numbers stay even is part of the routine. And how much fuel are we talking about? Here it is, straight from the manual. Each wing tank holds around 4,900 liters, which is about 3,900 kilos. And the center tank is the truly big one, over 16,000 liters, some 13,000 kilos, more than both wing tanks combined. In total, about 26,000 liters, almost 21 tons of usable fuel. That said, keep the idea and not the decimals. These figures are for this specific model and vary with the version and configuration of the airplane. And that is the fuel quantity indications. 3 gauges, 1 per tank, each with its exact digital figure and its arc for the quick glance, all in kilos. The center tank that burns first, and the 2 wing tanks that must stay balanced. 3 numbers the pilot never loses sight of for the whole flight. The same gauges that tell you how much fuel you have left have a second job, an even more important one, warning you when something goes wrong. And they do it in a very clear language. When everything is fine, the numbers are white. But as soon as a problem shows up, that gauge turns amber and spells out what is happening. Let's look at the 3 warnings the fuel system can give you. We are on the same upper screen as before, the one with the 3 gauges. Here, on the upper display unit, is where the fuel alerts appear. Notice that the warning does not come up on a separate screen. It is the gauge itself that changes color and writes the word right on it. Let's go through all 3. The first one is the most obvious. It is the low alert, from low, not much left. When a main tank, the one in a wing, drops below 907 kilos, that gauge turns entirely amber and displays low. It is the airplane's way of telling you, careful, this wing is running low. And it does not go out the moment you gain a little back. To clear the warning, you have to recover quite a bit more, 1,134 kilos, so it does not keep flicking on and off on you. The second one is more subtle, and that is exactly why it is so useful. It is the con fidget alert from configuration, and it only shows up on the center tank gauge. It triggers when there is plenty of fuel left in the center tank, more than 726 kilos, but its pumps are not delivering it, either because they are giving no pressure or because you have left them off with an engine running. It is a hugely important warning because it means you are carrying usable fuel that is not reaching the engines. It is telling you, you have fuel right there. Turn those pumps on. And the third one watches the balance. It is the imbal alert, from imbalance. It triggers when the tank in one wing and the tank in the other differ by more than 453 kilos, and it always appears under the tank that has less. One wing much heavier than the other forces the pilot to correct, so this warning tells them which way the imbalance goes. A couple of details. It does not appear on the ground, where it is not a bother. And if a low alert is already on, low takes priority and the imbal stays quiet, so you are not juggling 2 warnings at once. And those are the 3 fuel warnings, all in amber and all written right on the gauge. Low, when a wing is running low. Config, when there is fuel in the center tank that is not reaching the engines. And imbal, when one wing weighs quite a bit more than the other. 3 words the pilot understands at a glance, and that tell them exactly what to do. A tanker truck loads several tons of fuel into a 737 in just a few minutes, and nobody has to climb onto the wing with a hose. How? With a single-point refueling system, all tucked away under the right wing. Let's open that little access door and see where the fuel goes in and how it's all controlled from outside. All of this is outside the airplane, on the leading edge of the right wing, behind an access door that opens from the ground. Inside is the fueling station, the receptacle the fuel enters through, the valves that distribute it, and the controls to manage it all. Let's go piece by piece. First, the front door. This is the fueling receptacle, the single inlet through which all the fuel enters. The operator connects the truck's hose here, and the fuel flows in under pressure through this one point. From there, once inside the airplane, it's distributed to the tanks. One single point to fill everything, fast and safe. But the fuel doesn't just go to any tank. It has to be directed. That's the job of the fueling valves, 1 per tank. With the battery on and the door open, fuel pressure itself opens the right valve and lets the fuel into that tank. These are the valves that, commanded from the panel, decide where every drop ends up. And what if the electrical control of a valve fails? That's what the solenoid override is for. It's a lever that opens the valve by hand, purely mechanically. If fuel pressure is available, the valve opens all the same, with no electricity. A simple backup, so an electrical fault never leaves you unable to refuel. And here's a very elegant safety detail. Look at the door relay. A proximity sensor watches that access door. While it's closed, the entire fueling system is unpowered, dead, so nothing can activate in flight. As soon as you open it on the ground, the system powers up and the panel lights come on. In other words, the very act of opening the door is what brings the system to life. So far, we've been putting fuel in, but sometimes you need to take it out. That's what the manual defueling valve is for. When opened, it connects the engine fuel feed system to this station, letting you defuel the airplane or transfer fuel between tanks on the ground. Closed, it keeps the engines isolated from the fueling station. And we finish with the most analog thing on the whole airplane. These are the fuel measuring sticks. Spread out under the wing, 6 for each main tank and 4 in the center tank, they are literally rulers you pull out by hand to measure how much fuel is in each tank. Why bother when there are electronic gauges? To cross-check. If the stick and the gauge don't agree, something is wrong. The simplest technology, keeping an eye on the most advanced. And that's the 737's fueling station. One single receptacle through which all the fuel comes in. Valves that distribute it among the tanks. A mechanical backup in case the electrics fail. A door that powers up the system when you open it. A valve for defueling. And even handheld rulers to measure fuel the old-fashioned way. All under the wing to fill and empty the airplane from the ground. Refueling an airplane is nothing like filling up your car. There's no filler cap on top where you stick the hose. The fuel goes in from below through a single point under high pressure, and everything is controlled from a small panel hidden in the edge of the wing. This is the panel an operator uses to fill the airplane without ever setting foot in the cockpit. And here's the first surprise. This panel is not in the cockpit. It's outside, on the leading edge of the right wing behind an access door. It opens from the ground with the airplane parked, and from here, the entire fuel load is managed. Let's look at its controls. Let's start on the left. This switch is spring-loaded and always returns to the center, to off. Up, in test gauges, it runs a check. It verifies that the fuel quantity indicators actually work before you trust them. And down, in fuel door switch bypass, it has an emergency trick. If the system doesn't power up on its own when you open the door, this position powers it manually so you can still refuel. Right above it, you have a row of blue lights. These are the fueling valve position lights, one per tank. Their logic is very handy. They light up blue while that tank's fueling valve is open and the tank isn't full yet. And what happens when the tank fills up? The light goes out on its own. That way, the operator can tell at a glance which tanks are still loading and which ones are already done. Below them are the controls that actually move the fuel. These are the fueling valve switches, one per tank, with two positions, open and closed. In open, they open that tank's valve and let in the fuel arriving under pressure from the truck. In closed, they shut it off. With these, the fueler decides exactly how much fuel goes into each tank. And to see how the loading is going, there's no need to climb up to the cockpit. Right here, on the wing panel, are the fuel quantity indicators, the same numbers the pilot sees up top, the fuel in each tank. Tank 2, the center tank, and Tank 1, in kilograms. So the operator watches each tank's figure climb in real time while refueling and stops when it reaches the amount that was ordered. And that's the wing fueling panel. A switch to test the indicators and to provide emergency power, blue lights that tell you which tanks are still filling, switches to open and close the flow to each tank, and the same gauges from the cockpit repeated down here. All so the airplane can be filled from the ground through a single point without setting foot in the cockpit. Inside a half-empty fuel tank, there isn't just liquid, there are vapors. And those kerosene vapors, mixed with air, can become explosive. For years, that was a real risk in aviation. The solution modern airplanes carry is as elegant as it is discreet. Fill that empty space with a gas that doesn't burn. That's the job of this system, the nitrogen generation system, one of the most important safety systems that almost nobody ever sees. The idea is simple. The system separates nitrogen from the air and feeds it into the center tank, displacing the oxygen. Without enough oxygen, those vapors can no longer burn. And here's the curious part. This panel is not in the cockpit. It's outside, in the right main landing gear wheel well, so maintenance personnel can see at a glance whether the system is working. There are 3 lights, and they work like a traffic light. Let's start with the top one. It's the operational light, in green. When it's on, the message is the best one possible. The nitrogen generation system is fully operational, doing its job of inerting the tank just as it should. Green, everything in order. The middle one is an in-between warning. It's the degraded light in blue. It means the system is still working, but in a degraded mode, below its normal performance. It's not a total failure. The airplane can keep operating, but maintenance knows that unit isn't giving 100% and should be checked. And the bottom one is the bad news. It's the inoperative light in amber. The system is inoperative. It's not generating nitrogen. And pay attention to one important detail. If no light is on at all, that's not a good sign either, because that also means the system is inoperative. In other words, for peace of mind, the one you want to see lit is the green one. And that's the nitrogen generation system, a system that fills the center tank with a gas that doesn't burn so its vapors can't explode, signaled by 3 lights in the wheel well, a safety traffic light for maintenance. Green, all good. Blue, running below par. Amber, or no lights at all, inoperative. Invisible from the cockpit, but one of the systems that gives you the most peace of mind. And that wraps up the 737 fuel system, section by section. If this was helpful and you want us to keep breaking down the entire aircraft, subscribe to the channel. See you in the next system.